Hey, this is Mr. Stoy, and today we're going to be looking at lesson 3.2.2, exploring an area model. And the idea here is that we're given an equation, and we're going to use our algebra tiles to model that equation, and then from that, we're going to create a rectangle using those algebra tiles so that we can find the base times height, or area, of that rectangle. From that, we will then use what we find in that rectangle, the base and the height, and we're going to create an area statement using them. All right, well, our first thing is to take this equation, and this comes out of problem 3-46, letter E, and that equation we're given is 2x squared plus 10x plus 12. We need to actually take all of the algebra tiles that represent that equation and then create a rectangle out of it. All right, so I'm going to go over to our algebra tiles tool in CPM, and you can find the link in the textbook for that. At any rate, what I'm going to do is I need to pull out all of the tiles I need for this equation. Well, they tell me how many of each I need. For example, the equation is 2x squared, so I need 2x squared tiles. Then it's plus 10x, so now I'm going to pull out 10x tiles. 4, 5, 6, 7, 8, 9, 10. Okay, now it says plus 12. Where 12 is a number, we represent those using individual 1 tiles. And I need 12 of those. So there are 6 there, and then I need 6 more. One more, and we got it. So these are the algebra tiles that we use to represent that equation, 2x squared, that's down on the bottom, plus 10x, those in the middle, plus 12, and we got the 12 ones on the top. Now we want to build a rectangle out of these tiles so that we can then find the base times height of that rectangle for our area statement. All right, well, the easiest way to start these is always anchor it in the lower left with your x squared tiles. Now I can put the x squared tile on top, or I can put it on the side here, but either way I need to put those two as my anchoring point. One of the things I notice right off the top is that I can then connect my x tiles down here to kind of build a base. Not sure how many I need. And then I can also go up on top of the x squared tiles by double tapping to switch it, and then stack there. And when I do this, I'm basically trying to build a rectangle from all of the tiles that I have. Looks like there's only one left, so it must go down there. Okay, now I'm going to place all of my 1 tiles, and conveniently you can see here that that's a 1 by 1 inside there, so I can just start filling in this gap with all of these 1 tiles. Hopefully those are going to be exactly what I need to complete the rectangle for this particular equation, and it's looking good. Put those in there. Notice when it turns green and then it connects it. So that's all you have to do is move it where it turns green and then connects it. Okay, so now I've got this rectangle that I've created with all of those tiles that were representing our equation. And then I can screenshot that, and we're going to find the base times height of that particular rectangle and build an area statement off of that. Because remember, area is base times height, and if I can do that with this rectangle, that gives me the area of it, which I can then use. All right, back to Notability. Well, it turns out I've already screenshotted that earlier, and so I'm just now going to grab that earlier photo if I can. And there it is. Add that in. Let's stretch it out, make it a bit bigger so we can see it. Okay, there we go. So the idea here is I want to be able to find the area of this rectangle, and area in particular that we want to find is base times height. So I want to find the area, which is base times height. Well, when we did an introduction to algebra tiles, we found the side lengths of all of the tiles that we had. So if I look down at the bottom of this for the base, all I have to do is find the lengths of each individual tile. There, 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 and there, and add those together, and that will give me the base. Okay, well, I've highlighted them. Now I can do it. Well, since we went through the side lengths of each of these, I know that the side length of an x square tile is x in length, and I have 2 of those. So my base starts out 2x, and then I add to that these 1, 2, 3, 4 side lengths, which for the x tile, the small side is a 1. So there's 4 of those, so it's going to be 2x plus 4 for my base. Now I need my height, and my height, I do the exact same thing where I'm basically going and finding the length of that, that, and that, and adding those together, and that will give me then my height. And looking at those, well, I've got 1x, that's the side of the x square tile, and then I've got 3 again of the small side of the x, which is 1s or 3. And now I've got it. I've got basically my area, base times height, of this rectangle that represents our equation. And that product, and that's what we call it, the product of the base times height is 2x plus 4 quantity times x plus 3 quantity. Okay, well, this is great. Now that I have the area of that, I want to do an area statement. Well, you might remember that area can be both base times height, but area can also be adding up the area of every individual tile that I have. And that would be the sum. Okay, and I'm not sure why my pen doesn't want to work. Sum of all tiles in rectangle. Okay, well, look, it gave us that already. It's the equation. I have 2x square tiles, and the name of the tile is the actual area of it. Okay, so x squared, I got 2 of them, and then I have 10 x's, and I have 12 one tiles. So I already have the sum of all those individuals. Well, if the base times height is equal to the area of this rectangle, and then the sum of all the individual tiles is equal to the area of the rectangle, well, then my product must equal my sum since they're both equal to the area. And so now we can do what's called an area statement. And the area statement is nothing more than product equals sum. Okay, nice. Well, we've got it for this. We found this rectangle. We got the algebra tiles out to represent the equation. We built the rectangle. We got base times height. And we have the sum of all the parts. So we have product and sum. We can now write our area statement for this particular equation. Okay, well, product was 2x plus 4 times x plus 3, base times height. That has to be equal to then the sum of the parts. And the sum of the parts were, well, I had 2x squared tiles, I had 10 x tiles, and I had 12 1 tiles. And that's the sum of the parts right there. It's basically adding up all the areas of all the tiles I have. And that's exactly what 2x squared plus 10x plus 12 is. This area statement is showing us that this times this equals that. We have an equation, and it's showing us that if I multiply the base times the height, and I can do that operation, it's going to give me an equation that represents the area of that rectangle. Well, we're doing this later in the course, so this is kind of a preview, and it's showing us a very interesting way of using algebra tiles to model this situation and showing us how the sum of the parts is equal to this base times height product. All right, thank you.